Hello everyone, hope you're doing well. In this tutorial, I'm going to show you all the steps to design a questionnaire that fits your study and tests your variables, in addition to how to analyze it using some tools like SPSS and SmartPLS. So stay tuned till the end of the video so as to avoid making some mistakes, especially in the questionnaire design, and not only in the questionnaire design, but from choosing a topic to coming up with the conceptual framework or model to coming up with the research hypotheses and the variables, in addition to finding some items or questionnaires that can test exactly the variables that you have in the study. So this is what we are going to see in this sample. So you know that this first, the topic here is on the effect of motivation on academic burnout among students. So the conceptual model that has been developed is as follows. It has motivation as an independent variable, and it has burnout or academic burnout as a dependent variable or DV, and there are some control variables like gender, semester, generation. And here the H1 means that there is only one hypothesis that can be tested here, like the effect or the influence of motivation on academic burnout. Since the direction of the hypothesis here says that motivation affects negatively academic burnout, this is what we call a one-tailed hypothesis. So here we have two variables, as I said. In the independent variable, or we call it the construct, is motivation, whereas the dependent variable or another construct, which is the academic burnout. And here we have the survey from which we can operationalize and test these two variables in the study. Like motivation here is divided into different dimensions or sub-dimensions, like internal motivation, IM. These are the items. It has 3 items and there are 3 statements. And of course the Likert scale is 5-point Likert scale, ranging from strongly disagree coded as 1, disagree coded as 2, neutral coded as 3, agree coded as 4, and strongly agree coded as 5. And the same for external motivation. These are like the statements, and this is the Likert scale. These are like the places or the placeholders where respondents can put their answers, and the codes that I just stated, be it in person or online. So we have also e-motivation. So motivation is multi-dimensional variable. It has 3 sub-dimensions, whereas academic burnout also has some dimensions like exhaustion, like cynicism, and professional efficacy. So these are like the 3 sub-dimensions of academic burnout. However, we are only interested in the overall impact of motivation, be it internal, external, or e-motivation on academic burnout, be it exhaustion, be it cynicism, or be it also efficacy or professional efficacy. So here we have already collected the data, and we have a Likert scale survey that we can just choose here, which is this one. So after designing the survey, it can be simply adapted from previous studies. I will just take these items and put them in Google Forms like this, with the title of the questionnaire, with the description, like in terms of the research ethics, once an IRB or an institute review board is required, etc. Then gender, semester, those demographic variables, generations, and then here we put the statements this way, just by using multiple choice grid and putting the Likert scale from strongly disagree to strongly agree. And here we can require a response in each row so that we can make these items obligatory in terms of the whole survey. So once we finish this, we can just click publish, and here it will ask us to just publish it. And then by using here this one, I will just copy the responder link, and I can shorten it, and I can copy it and share it on social media groups if I'm using convenience sampling and other procedures, or using an RQ or QR code to collect data in person and online. So this is how we can do that. After that, once we finish the data collection, we can just go to the response here, and we can link this to a Google spreadsheet where we can simply download the data, like this one here. Go into file and download, and then Microsoft Office Excel, and here we can collect and download the data. After we collect the data, we need to code these items by assigning numbers to each Likert scale anchor, so that we can process them using SPSS or Excel or any other instrument or rather tool that can be used with regard to this data or to the statistical data analysis and processing. After that, once we do that, we will have something on SPSS like this that has two parts: the data view that has the items and the data, and the variable view that has the statements, the variables, and the codes or the labels that you can see here. And these are the codes from 1 to 5, and here the same for the other scale, from never to every day, which is again a 7-point Likert scale, not a 5-point Likert scale. So this is how we can do it. After that, we can simply go to analyze, and then we can start running the reliability analysis by going to scale, and then right click here. You need to put, for example, those codes so that you can identify the questions in the questionnaire. So you put, for example, from internal motivation to e-motivation. These are all, let's say, the items for motivation construct or variable, and I click OK. And what will happen is that I will have the Cronbach's alpha reliability of the motivation scale. There are 9 items, and the Cronbach alpha is less than 70% or 0.7 or here it is 0.602, which is low, so we need to increase it. To increase it, we just go to reliability analysis, and we can see scale if item deleted, and continue and click OK. And here we can see which items can be removed or reverse scored, so that we can improve the reliability of the motivation scale, which is a main variable and main independent variable in the study. The second variable is the academic burnout. So for the academic burnout, I will take all the dimensions of academic burnout and put them here. So for burnout, we're just going to click OK and see. So for burnout here, it is reliable. It is above 0.7, which is good. So here we can combine all those items in one scale or one variable, so that we can run, for example, regression, etc. Using data transformation. Otherwise, we can simply see how we can improve the reliability before doing this, because if the reliability is not improved, there is no way that we can move further, because the measurement model is necessary when it comes to the structural model. So I will do the same here, but using Amos. Let's say not Amos, there is Amos, but also there is SmartPLS, or for structural equation modeling. So I will just go to PLS SEM and go to new project, and let's call this motivation, and for example, academic burnout, and then create. And here we could go to import data, and I will just import the SPSS data. Here there are like some missing variables that I can code as 99 and apply markers, and this will be turned into green, and click import. And once I have the data imported, here it tells me the number of indicators or questions, in addition to the sample size 104 and the missing values. In case there are missing values, I will just click back and create model, and let's choose PLS SEM, and let's call it MM, which means measurement model, and save. And here I have those variables. So for the motivation variable, I will simply put all those items here, and I will call this, for example, motivation, and click enter. And for the academic burnout variable, I will simply put all these variables or items here, and I will call that academic burnout. So here I'm not interested in the sub-dimensions, and I can simply draw an arrow from motivation to academic burnout. So here is the motivation variable or construct, we call it a latent construct, because it's not visible, and these are the observed indicators that are again sub-dimensions, like internal motivation, external motivation, and e-motivation combined together to form the motivation construct. And these are like the sub-dimensions of the academic burnout construct. So here I can simply click calculate and run PLS SEM algorithm and start calculating. Here it tells me that reading score matrix of complete data set, and here check your data file. I can simply see there is a problem with the data file. Please check its setup. I can just see if there are like some problems and what may be causing the problems before running the analysis. Can go for bootstrapping, so I could just have the same problem. So these are like some issues that you can have when it comes to data analysis using SmartPLS. So just go back and then go to PLSM and here, and I will simply see what could be the reason behind this by going to the data and seeing if there are like some issues with the data. It seems that the timestamp is causing the problem. So what I will do is that I will just remove the timestamp from the data, clear it, and I can remove any external, let's say, variable that may be causing the issue, and then click save. And what I will do is that I will simply go to the data set, right click, and then I will import data file, and I will simply import it here and then put the marker -99 this time, apply marker and click import and go back. And then here I would need to remove this data set, and then I will just keep the latest one that I just uploaded, and I need to go back to the model, calculate, and click PLSM and start calculating. Here again it tells me that reading score matrix of complete data set, check your data file. So there is a problem with the data file, please check its setup. So let's just go back to the setup of the data file and see what could be the problem. Here in the following you can see problematic line from your file. So here don't forget the motivation is tool, which more students do not have. So there is this problematic line. Let's go back to the data, and this stage is called data cleaning. Here to do data cleaning, simply I can run descriptive stats and frequencies with some charts, and I will put all those variables. So here I'm just doing basic descriptive statistics, especially frequencies and percentages to check. So it seems that all of them are okay by screening. It seems that there is an open-ended question that I just observed, which is this one. I need to remove it, this one. So I will just clear this one, save the data again, close it, go back to SmartPLS, and then what I can do is that I will just go back, right click, import data file, and simply I will just import this one, put the marker as 99 or -99, import, and here I will simply delete the previous one, this one, and then go back and calculate and then run PLSM algorithm, and now it has been solved, you see. So there was an issue with regard to an open-ended question there. So anyways, you see sometimes there are a lot of troubleshooting that you need to do before getting things done. So it's not a straightforward process, and don't get frustrated. You see here there are like some items that are negatively loading. We have the negative sign, minus sign, especially for internal motivation that do not align with those variables. So what will happen if I just remove the internal motivation from the motivation construct? I think this will improve the validity. So what we can do simply is that we can just click delete and remove anything that is, let's say, less than 0.5 or 6 or 7. Sometimes the threshold, recommended threshold is 7. So let's just, once I delete this, I need to check whether we have the same good results here. For example, the R square. So you could see the threshold by going to the chart. It needs to be green like this one. So here it respects the threshold. The F square is green, is good. And the construct reliability and validity, it seems that the reliability has improved to 0.7 for motivation. However, for the composite reliability for the academic burnout and the average variance extracted for the convergent validity seems to, or this value especially seems to be low for both scales. This means that those scales do not have what we call convergent validity. So the items cannot be grouped together to form those two constructs. So here we have like an overview. You could see it as a bar chart for each type, and you could see the problem here for academic burnout in red. So what is good about SmartPLS is that it simplifies the process and it gives you the color coding to see which problems there are. So there are like heterotrait monotrait ratio. We have HTMT is in green, which means how the items are similar or different, like heterotrait or monotrait from the others in terms of the scales and cross-loadings as well. We have the Fornell Larcker criterion about the off-diagonal and on-diagonal values that should be greater for the loading, like academic burnout should have higher loading here than here. So that's what it means. And this one should be higher than this, which is the case. Then we have the cross-loadings. So here those items should load perfectly well into their corresponding constructs so as to avoid cross-loading. For example, cynicism here is an item within academic burnout, so it is loading better here than here. So you see that these values here, you can just put it as a heat map so that you can see the ones that have issues and that can be removed. For example, here internal or extrinsic motivation is loading into motivation more than it is loading in academic burnout. This means that the two constructs are distinct from each other. That's why they are loading differently. So here's reduced self-efficacy. It seems to be loading negatively in both sides. So what we can do is that we need to improve this. So we have a problem with regard to what we call convergent or discriminant validity, and especially in terms of the cross-loadings. For the collinearity statistics, it should be between -5 or -5 and +5. Here it respects the range. And then the model fit indices that are not necessarily in structure equation modeling when it comes to SmartPLS. So what I can do, simply I can go back to the data and then I will just take out the items. Normally I should just reverse code them so that I can increase those scores. But here they seem to be low, so I will just remove them from the model, and I will keep just the ones that are loading perfectly well. For here we have all of them loading above 0.6 and 0.7, which is good. Here I could further remove this item and this item. Simply for internal motivation, it seems that there is only, for extrinsic motivation, there is only one. So it seems that external motivation is not the one that is significant here. So I will just remove it. So basically for motivation, what this tells us, it tells us that students have mostly e-motivation. This is what is loading more here. So these numbers tell us that for the motivation, may not have more intrinsic motivation or extrinsic motivation, but it seems that it is the e-motivation that is influencing motivation construct more. People are not motivated at all, and this is proved using statistics. Then we have those variables like exhaustion. It seems that they are not exhausted. So we remove this exhaustion number 1, remove exhaustion number 2. We keep those items here, cynicism and some items of exhaustion. So basically academic burnout, especially when it comes to cynicism, like dark view of life, and exhaustion, these are like the two that remain here. So you see how we removed a lot of items so as to improve the model. So don't remember or don't forget to save your model. So you go back and let's see what we can have. So we can simply calculate and rerun the PLS SEM algorithm stop calculating or start calculating, and here we can go back and see the R square, especially the bar chart, it seems green. The adjusted R square, it seems green. The F square, when it comes to the bar chart, it is green. The constructor reliability and validity, so here everything is green, meaning that everything is reliable and is respecting what we call average variance extracted for what we call convergent validity, and this is for internal consistency. Then we have the average variance extracted as a chart. Then for the discriminant validity, the heterotrait monotrait ratio of correlation is good. Then Fornell Larcker criterion is also good. These values are greater than the others, which is better. Then the Croasloadings, you could see the Croasloadings here for Amotivation loading perfectly into motivation, and cynicism loading along with exhaustion. They are loading positively well and higher in terms of academic burnout. We already saw that on the model from those arrows, so these are simply here in a table. And then for the collinearity statistics, you could see that the collinearity statistics, there are like no red flags, so basically everything is good except for cynicism 2 that seems to have higher collinearity. And the collinearity can be done for the outer model or the inner model. So that's it. So here I could simply export these results as an HTML or as an Excel file. So these are all the ways I could export the results and save this, and then I could edit. So after verifying the measurement model, we need to move to the hypothesis testing, or what we call the structural model, by going to calculate, bootstrapping, and here we can set this up to 10,000 subsamples. This is the recommended subsample according to Hare et al. In their latest publications. I could just start calculating, and then what will happen here in the structural model, I could just go to the path coefficients, and I could see that there is an influence of e-motivation, not only motivation, but e-motivation or on academic burnout by 55%. And here academic burnout, to be further specified, it involves cynicism and exhaustion. So these are like two variables that are causing academic burnout according to the data that we got. Students have more what we call e-motivation, and they suffer from cynicism and suffer from exhaustion. So if we could just go back to the survey and look at those exact questions, we could see, for example, e-motivation, like I have got used to go in there, but honestly I don't exactly know why I do it. I once had good reasons for going to university, however now I wonder whether I should continue. Honestly, I do not know. I really feel that I'm wasting my time at university. So this is like the e-motivation that students have the most when it comes to their academic studies. And when it comes to exhaustion and cynicism, especially this one, like I have become less interested in my studies since my enrollment at the university. I have become less enthusiastic about my studies. I have become more cynical about the potential usefulness of my studies, and I doubt the significance of my studies. So these are like the variables that have been statistically proven in this model and in this hypothesis that we need to specify. So we started with the general let's say vague construct motivation. We don't know whether it is internal motivation, external motivation, or whatever motivation there is. And then academic burnout, and we didn't know exactly what academic burnout is. It exhaustion? Is it self-efficacy? Is it what? But according to the statistics and according to the data, it seems that people have what we call, or students have what we call, e-motivation, lack of motivation, and cynicism, as well as exhaustion when it comes to their academic studies. Because there are like some items on exhaustion, like these ones. I feel emotionally drained by my studies. I feel used up at the end of a day at the university. I feel tired, especially these items, like 3, 4, 5, like the second part of it. Like here, I feel tired. Studying or attending class is really strained for me, and I feel burnt out from my studies. These are like the 3 items of exhaustion that are most predominant. So these studies or these findings are worth reporting, because you could just suggest solutions to the organizations to see how to help students cope with these problems and make them perform better. We could also control for the other variables like gender, semester, generation. Like here, I could simply run what we call a control variable and see if this can be influenced. Let's say for a control variable, let's say gender, need to go to the demographic variables here, gender, semester, generation. I could just put them here, or simply I could just do one by one, not a construct like this. So simply what I can do for a control variable is put gender here, and then I will put semester and generation. So I can do it like this, like in regression models, or there is another way that I can put the control variables, especially using Excel, so that you can see whether gender, semester, generation, and you could just do that step by step to see how each one influences the other. All right, so this is in brief how we can do it. If you have questions or remarks, do not hesitate to post them below. I hope now you understand how you can start from a theoretical model. You design questionnaire, you simply adapt those items from previous studies so that you can prove that they are reliable and valid, and then you test their reliability and validity, which are really important indicators, especially the Cronbach alpha reliability, the average variance extracted EVA for what we call convergent validity, then what we call the other one, like for discriminant validity, like the HTMT or the hetero trait monotrait ratio of correlation, in addition to the Fornell Larcker criterion, and the other one, the last one, which is the cross-loading, and finally what we have concerning the collinearity or multicollinearity that are used for regression analysis. So this is in brief how we can do it. If we have questions or remarks, do not hesitate to post them below. See you soon, and bye for now.